Greetings. Today we are presenting to you our PBL topic, which is Theoretical Analysis and 3D Model of Ackermann Steering System. Our group consists of Milan Chaudhary, Tarun Pachori, Vipin Singh, Nihal Shetty, and Pranay L. Mulepati. We have done calculations based on force analysis on the chassis structure. Force analysis. An analysis yielding the respective forces acting at any point of any member or part of a member of a mechanism obtained by using relationships for dynamic equilibrium in a plane rigid body subject to external forces within this plane and to internal forces due to its motion in this plane. Analysis of Ackermann steering mechanism. Ackermann steering geometry relates the steer angle of an inside tire to that of the outside tire. When turning, the inside tire travels a shorter radius than the outside tire, and thus must have a greater steer angle to avoid tire scrub. Classic Ackermann minimizes scrub by positioning both tires perpendicular to the center. It can have a significant impact on the tire wear. Ackermann analysis can also be used as a tuning tool in cases where classic Ackermann may not be the objective.
Hey everyone, this is Milan Chaudhary. In this video, I am going over the Ackermann steering. The name Ackermann comes from a guy named Rudolf Ackermann who actually patented this idea. Back before the Ackermann steering was around, some of the tire may slip because they have come to a different point. The Ackermann steering, the reason it exists is your tire do not slip when you go around a corner. Now, how you achieve this is by having a central point at which all your tires are rotating around. So you can see the angle of inner tire is greater than the outside tire. With the angle being greater, they can come to a central point, and then all four tires can rotate around one point, which means tires do not have to slip as they go around. If both tires are on the same angle, then they have to slip around some uncommon point. So it wouldn't work as well, especially at high speed. The Ackermann principle is great for solving this problem. The one thing we have to see when we look at this is each tire has a path of different radius. Now what that means is that all tires are rotating at a different rate. One at the outside travel further distance than one at the inside in the same amount of time. So it's rotating more quickly. Now what does this mean? This means right side is moving faster than the left side when we are going left hand turn, and vice versa if we are going right hand turn. Also what this means is the front tire, because it travels greater distance, as you can see, than the rear tire, they are moving faster than rear tire when you turn. This is the real reason you need a differential in rear tire, so that you can split the speeds between the front tires and the rear tires. Otherwise, you're gonna have understeering or slipping. Now the important points of having the Ackermann steering in your vehicle. First is the right side tire moves faster than the left side tire in the left turn, and left side tire moves faster than the right side tire in the right turn. Also, front wheel moves faster than the rear wheel at any turn. It also prevents tire from slipping, and it also provides better cornering.
Hello, myself Vipin Singh. I am going to explain the advantages and disadvantages of Ackermann steering system. The advantages of Ackermann steering system are: it has ultimate cornering ability, it has high turning radius, and it has improved steering response. And disadvantages of Ackermann steering system are: it increases the weight of vehicle, and it also increases the cost of the vehicle. Its linkages are extremely complicated.
Greetings to everyone, I am Tarun Pachori. Hereby I will be providing a brief explanation to the calculations we have made in studying the design of chassis members in accordance to the Ackermann steering design that has already been explained. Without wasting much time, I would like to draw your attention to the assumptions we have made based on already existing vehicles. We have taken the mass of the high performance vehicle to be 126.03 kgs, which will be 1.2 tons in weight, and the average velocity to be 60 km per hour, that is 16.67 meters per second. Here we have considered the chassis member to be a uniform circular rod made out of C40 steel and having an FOS of 1.5. The chassis member in the front wheel section are subjected to both axial and bending loads, wherein the inner wheel is subjected to axial tension and the outer wheel is subjected to axial compression. Using the concepts of design of machine elements 1 pertaining to members subjected to combined loading, we were able to conclude that the diameter of chassis members to be used should be 44 mm when the inner front wheel is taken into calculation perspective and 41 mm when the outer wheel is taken into consideration respectively.
Greetings, I'm Pranam Revati. Continuing with the determination of the dimension of the chassis members of a vehicle which operates on Ackermann's steering mechanism. Beams of chassis connected to the rear wheel are perpendicular to the direction of the centripetal force resulted by the turning of the vehicle. So those members are subjected to bending stress only, unlike members connected to the front wheel. Considering all the previous assumptions made and applying concepts of design of machine components subjected to bending, diameter of the chassis member connected to the outer rear wheel was determined to be 45 mm and that of inner rear wheel was determined to be 50 mm. Since the stress at any location shouldn't exceed the design stresses adopted, diameter of the chassis members of a vehicle shouldn't be less than 50 mm.
Good afternoon. Myself Siddharth. Our topic is motor generated unit kinetic. It has component of hybrid electric power unit. Unit is both an electric generator and motor, connected directly to the camshaft of internal combustion engine by gears. It performs two functions. Under acceleration, it helps the power engine, and under braking, it uses the energy that would have been dissipated as heat to recharge the batteries. It goes through that cycle several times, each lap drawing electricity to help the engine deliver power and generating electricity while helping the car to slow down. Over time, the side benefit has become apparent that modern F1 cars do not carry stator motors, but a car has traveled in several practice sessions or race will have enough stored energy to restart the engine, therefore duplicating the function of a stator.
The MGUK works just like any other generator does, the only difference being this can be used as an electric motor when we require it to. The MGUK works on the principle of electromagnetic induction. This uses an armature coil which is connected directly to the rear axle. As the rear axle stops accelerating or when the brake is engaged, this helps slow down the vehicle because of the resistance offered to the rotation of the armature coil. This means that the energy loss in the form of heat will be reduced.
The working of motor generator unit kinetic is it converts mechanical and heat energy into electrical energy. So the MGUK is an electric motor connected to the crankshaft and helps turn the crankshaft, therefore producing more power. The MGUK is directly connected to the rear wheels. It returns up to 160 bhp of power to the drivetrain. MGUH is an energy recovery system connected to the turbocharger of the engine and converts heat energy from exhaust gases into electrical energy. The energy can then be used to power the MGUK or stored in battery for later use. It is connected between the turbine and compressor of the turbocharger. Hence, when the hot gases spins the turbine, it generates electricity which is then used to spin the compressor. Therefore, there is no turbo lag.
The MGUK is very similar to what is found in a so-called hybrid production car. In F1, we have an electric motor that is connected to the petrol engine. During the braking phases, it recovers the energy that is normally lost in heat. We now recover a good part of that kinetic energy that is then stored in a battery. The MGUK can work in both directions, to recover or to supply energy. The MGUK electric motor is connected to the crankshaft through the timing gears. It helps turn the crankshaft, therefore producing more overall power. The MGUK is directly connected to the rear wheels.
The conclusion about MGUK motor generator unit kinetic is one of the most complex pieces of the F1 power unit, performing several roles. The MGUK is not just a generator, however, it also deploys energy from the ES, to the drivetrain, giving the car up to 160 bhp of additional power when car required. This energy can be also be deployed to the MGUH to support the turbo. And coming on to the Formula One braking generation, it creates a massive amount of energy. Massive amount of heat, so intense that brake pads glow red with the energy they are forced to absorb.
A very good day to everyone present. This is PBL Group 6 from Mechanical Department, 5th semester. The theme of our project is based on mechatronics, and our project is Arduino based automated braking and accelerating system. This project is presented to you by Satvik Roy,
Saksham Singh.
and Prince Prabhakar.
and we are guided to do this project by Dr. Avinash. So, let me give you a brief introduction about our project. Our project is based on automatic braking system based on an intelligent mechatronic system. The intelligent system is the Arduino, which controls the braking and acceleration of our model. Our model will consist of an ultrasonic sensor and receiver, whose main purpose is to detect obstacles in front of it, so that our model can stop and accelerate when there is no object in front of it, and accelerate when the road is free. The ultrasonic sensors are mainly placed on the front of the car to receive and reflect the ultrasonic wave signals. These signals actually give the Arduino an idea about how long or what is the distance between the object and the car, which allows the sensors to kick in and stop the car before an accident happens, and then which is done with the help of a microcontroller. The microcontroller detects the signals from the Arduino, from the ultrasonic sensor, and stops the car before it crashes into an obstacle.
Yeah, this is the circuit diagram of our project, and the components which we are going to use are the ultrasonic sensor, the Arduino Uno, wheels, rechargeable battery, some gear motors, resistors, transistors, and jumper wires, and obviously a base. Let me explain how our project is going to be work. An automatic braking system is an intelligent mechatronic system, includes an ultrasonic wave emitter, provides on the front portion of the car producing and emitting ultrasonic waves. An ultrasonic receiver is also placed on the front portion of the car, operatively receiving an reflective ultrasonic wave signal. The reflected wave, which is the detected pulse, gives the distance between the obstacle and the car or the vehicle. Then a microcontroller, which is the Arduino, is used to control the speed of the vehicle based on the detection pulse information to push the brake pedal and apply brake to the car and for safety purpose.
The flow chart of this working principle. The system works based on the ultrasonic ranging techniques, which is a non-contact ultrasonic distance measuring method. An ultrasonic braking system consists of an ultrasonic transducer or sensor unit, control unit, and a braking mechanism. The sensor unit consists of a pair of ultrasonic transducer, a transmitter, and a receiver. The ultrasonic transmitter, which is placed in the front of vehicle, which continuously transmit the ultrasonic waves in a fixed range. The transmission transducer generates the ultrasonic waves from a 40 kHz square wave output generated by the Arduino, which is fed to the transducer after amplification. The ultrasonic receiver, which is placed parallel to the transmitter, receives the ultrasonic signals that are reflected from the obstacles. Then these reflected wave of signals are fed to the Arduino. The Arduino calculates the distance to the object from the duration of time taken between the transmitted and received waves.
There are some objectives of this project. The main objectives of this project is to develop an intelligent braking system for automobiles. Nowadays, accidents are mostly caused by delay of the driver to hit the brakes or by the negligence by the driver. So, automobile industry needs this project this project. And the second objective of this project is to find the braking distance at various speeds as well as minimum distance before collision. And the third objective of this project is to reduce the road accidents, of course, which is caused by not hitting the brake at time.
Applications of this project is controlling automatic controlling of automobiles, automated guiding of vehicles in industries, which will help in automatically guiding carrier vehicles to respective shelves and for placing and packing materials in production line and in military spy service. Let me tell you how this project is beneficial for the society. The microcontroller-based mechatronics project can reduce road accidents and increase road safety by almost 70%, which is a very big number for a country like India, where road accidents happen every now and then. Even if the car malfunctions in the middle of the road and it goes off road, the sensors can automatically take over and it can detect obstacles in front of it and stop the car, thus saving the life of the driver and the passengers in the car. In the case of drunk driving, the if in the case of drunk driving, also if the car goes off road or it goes to another lane where another car is coming from opposite direction and the driver of the car is unable to see that or feel that, the sensors can automatically detect the distance between the oncoming car and this car and stop the car from crashing into the other car and save the lives of both the drivers. This was our entire project, and thank you so much.
Thank you so much.
Thank you.
Greetings everyone. Our project is an obstacle avoider vehicle done using an Arduino platform. The components used are an ultrasonic sensor, Arduino Uno, motor driver module, DC motors, wheels and a wheel support at the front. It works on the principle that first the sensor senses any obstacle in its path and then sends the signal to the Arduino where the signal goes to the Arduino receives the signal and decides on the action to be taken, and the robot moves in the path where there are less obstacles. We are still working on the code as there are some errors. Thank you. Team members are K. Shashank, Brijesh Shemar, Akash GK, Nitin, S. Shreyas.
Hello everyone. We are students of 3rd SEM Mechanical Engineering. We propose to make a multi-purpose agriculture machine which will do tilling, seed sowing, water irrigation. This mechanism will also be used for spraying of insecticides as well as pesticides. It will also be used for mobile charging. So and our group includes Bhavana DV, Vivekananda Vijay Kumar, Bhanu Pratap Singh, Chirant PT and me, Somesh Kumar. The methodology which we have decided is we have attached a tiller at the bottom part so that while moving this will be used for tilling of the ground. A seed sower is attached which has holes at regular intervals so that to make sure that the seeds are dropped at regular intervals and sowed properly. A pump, a water reservoir is placed with a pump, which is a suction pump, which will use to pump the water and will be sprayed to the grounds as the ground will get tilled and the seed will be sowed. Now, our vision is also to do using a generator. The motion of the rotation of the generator will create output voltage. This output voltage will be fed to the rectifier, and using this rectified voltage, which is converted from AC to DC. This DC voltage will be fed to a capacitor for leveling out of the DC voltage and to obtain a positive steady voltage. This, using a voltage regulator, the voltage generated will be so high, this voltage will be dropped down and will be used for charging of the mobile phones. As of now, because of the lockdown and because of everybody is in different geographical areas, we cannot come together and do this. So the electronics part, we are not able to do it for a mobile charging, but we have used it for making the bulb glow. Means we just wanted to demonstrate that our power which is generated is used for glowing a bulb, which can be seen. Thank you. So this is our process, and this is how it will be attached, and power is used for generation, and this is used for lighting of a smoke bulb.
So good morning, this is the prototype of piezoelectric generator. So these are piezoelectric plates connected in series. So these plates, when applied pressure, produce an AC voltage. This is an example for that. Like, this is an LED strip. So just by applying some pressure on piezoelectric plate, you can see that the light blinks. Yeah, so like if you apply pressure, the light will blink. This is, yeah, like, so this is just an external model to show that piezoelectric plates can generate some certain electricity. So it's just a singular mat. It's just a singular mat with piezoelectric plates connected in series, which directly produces electricity on pressure. It will produce more electricity when it's pressed as an overall, and it doesn't need to be tapped or hit hard. Just a mild pressure is enough on the crystal. So the piezoelectric plate has the crystal here in between, the white part, which consists of the crystal in the white part. So when that part is pressed, there is mechanical. So good morning, this is the prototype of piezoelectric generator. So these are piezoelectric plates connected in series. So these plates, when applied pressure, produce an AC voltage. This is an example for that. Like, this is an LED strip. So just by applying some pressure on piezoelectric plate, you can see that the light blinks. Yeah, so like if you apply pressure, the light will blink. This is, yeah, like, so this is just an external model to show that piezoelectric plates can generate some certain electricity. So it's just a singular mat. It's just a singular mat with piezoelectric plates connected in series, which directly produces electricity on pressure. It will produce more electricity when it's pressed as an overall, and it doesn't need to be tapped or hit hard. Just a mild pressure is enough on the crystal. So the piezoelectric plate has the crystal here in between, the white part, which consists of the crystal in the white part. So when that part is pressed, there is mechanical stress, which is converted into electrical stress. in AC form. So to store this energy, we need a circuit which can convert AC current into DC current. So here is a prototype of the circuit. So these are piezoelectric plates, same as these, connected in series. So when applied with pressure, they will produce AC voltage of varying voltages. So to make this AC voltage into DC voltage, first we will use a stable AC to AC converter. This is a 12 volt AC to AC converter. We can also use a 6 volt or maybe higher depending on the amount of voltage generated from the piezoelectric plates. So if this is a 12 volt that we are using, because if you use more plates, then you can use a higher voltage transformer. So this is a transformer which transforms AC to AC voltage. It reduces the voltage to 12 volts, or and this is a full wave bridge rectifier. So this converts the AC voltage into DC voltage, and further this is a capacitor. So this circuit is a setting which converts AC voltage into DC voltage, and we lack a multimeter, but if we had a multimeter we could show that there's a stable 12 volt DC current generated.
This is modification of scissor jack. Scissor jack may create problem of waist pain or back pain because of uncomfortable position of crankshaft. This problem is solved in this design by applying bevel gear arrangement. This assembly contains base frame. Base frame has 4 legs on which the whole assembly is mounted. Bevel pinion is supported with pinion shaft and bearing block. Handle is attached with pinion shaft. Power screw has Acme threads on it, which is assembled with nut and bevel gear. Bevel gear and nut are welded together. Bevel gear is push fitted with using axle thrust bearing with base frame. As soon as we rotate handle, it will rotate bevel gear because they are mounted on same shaft. Bevel pinion is engaged with bevel gear. Bevel gear start rotating. Nut which is welded with gear also rotate. This causes reciprocating motion of bolt. Bolts start moving along the upward axis. This motion can be used for lowering or raising the load or weight. This is reliable and safe and time saving arrangement of screw jack.
Good afternoon, everyone. Welcome to our PBL presentation. Our topic is drag reduction system in an F1 car.
So reduction system is an adjustable rear wing which can be used to facilitate overtaking. The drag reduction system is a form of a driver adjustable bodywork aimed at reducing aerodynamic drag in order to increase top speed and promote overtaking. It is an adjustable rear wing of the car which moves in response to the driver's command.
So this is a graphical illustration of where the DRS is incorporated onto the F1 car. It is incorporated onto the rear wing of the car, which moves 50 vertically upwards, and this is the rear wing of the car.
So these are the materials generally used in making of a F1 car. But when it comes to the revving, titanium is preferred. Although titanium is two-thirds heavier than aluminum, due to its great tensile strength, titanium is used. You can see the tensile strength of titanium is 1186 megapascal, whereas aluminum has only 241. So how it basically works is when a driver enters the DRS detection zone, he adjusts the revving and the flap lifts up by a maximum of 50 mm, therefore reduces downforce and increases speed by around 15 miles per hour.
So, drag is basically the downforce acting on the car, which develops when the air flows over the car. Since the F1 cars travel at very high speeds, around 330 to 350 km per hour, it is very important to keep them stable and on the ground. How drag develops? Drag develops when the cars are moving, most of the air flows over the car, so that and very less air will be flowing below the car. So the air which is flowing below the car tends to lift the car up, and since most of the air flows above the car, the downforce will be more when compared to the lift, and it keeps down, and this downforce is known as drag. As you can see on the screen, this is the drag equation, which is given by CD into rho into V square into A by 2. Here CD, here CD is the drag coefficient, and rho is the density of air, velocity, V is the velocity of the car at which it is moving, A is the reference area, which is basically the front area of the car.
Now, I'll be talking about a situation that arises called dirty air in drag. This mainly happens when two F1 cars are racing in the track, and the air behind the first car tends to be a lot more pressurized. This is because of the high speeds at which these cars travel. And as you can see, there's a very high pressure region just behind the first car, due to which the second car just behind has to undergo a great resistive force. And this is called as the dirty air phenomenon in drag. This is a very highly unpredictable flow, and this is overcompensated by the design and the structure of the F1 car.
So the rules when you're using the DRS uh, is permitted when these two rules happens. The following car is within 1 second of the car to be overtaken, which may be a car being lapped. The FIA may be or the FIA may alter this parameter race by race. The following car is in an overtaking zone as defined by FIA before the race, commonly known as the DRS zone, where the DRS can be used only in the permitted zones. Further, the system may not be activated on the first two laps after the race starts or restarts, uh, or before a safety car comes. The system cannot be used by the defending driver unless there's a 1 second gap between the another car. The system may not be enabled if racing conditions are deemed dangerous by the race conditions like rain or any other issues. Like the drivers are only permitted to use the DRS in the designated overtaking zones. Uh, a dashboard light notifies the driver when the system is enabled so that he can use the DRS. The driver can also see the system
deployed in his wing mirror. The system is deactivated when the driver tries to release the button or uses the brakes.
Now, I'll be talking about this CAD model that we had prepared. So this is the CAD model of an F1 car. So the main aim of an F1 car is to reduce the amount of drag force that comes at such high speeds. So as you can see, it is in a very streamlined position, which is highly suitable aerodynamically. And the back part of the F1 car is fitted with the rear wing, which is shown as follows. So as you can see, this is the rear wing of an F1 car, and these two are the flaps. So when the driver actuates the button, the bottom flap undergoes the actuation and it lifts by around 50 mm, which creates a the gap in between the flaps, which allows a 15 miles per hour difference for the overtaking driver. And as you can see by this simulation, this is the simulated force and velocity magnitude that could be generated in the flaps. So the light blue regions are the regions of low velocity, and as the air enters into the flaps, it is at very high velocities, and as it exists, it creates a lower pressure. So thus, as you can see by this simulation. So thank you for watching this presentation, and goodbye.
Mechanical stress, which is converted into electrical stress in AC form. So to store this energy, we need a circuit which can convert AC current into DC current. So here is a prototype of the circuit. So these are piezoelectric plates, same as these, connected in series. So when applied with pressure, they will produce AC voltage of varying voltages. So to make this AC voltage into DC voltage, first we will use a stable AC to AC converter. This is a 12 volt AC to AC converter. We can also use a 6 volt or maybe higher depending on the amount of voltage generated from the piezoelectric plates. So if this is a 12 volt that we are using, because if we use more plates, then you can use a higher voltage transformer. So this is a transformer which transforms AC to AC voltage. It reduces the voltage to 12 volts, and this is a full wave bridge rectifier. So this converts the AC voltage into DC voltage, and further this is a capacitor. So this circuit is a setting which converts AC voltage into DC voltage, and we lack a multimeter, but if we had a multimeter we could show that there's a stable 12 volt DC current generated.
This project is based upon the implementation of Smart Deployed Speed Braking System conducted under the guidance of Professor Kiran MD. Speed braking equipments currently in use are a reliable source in large multi-lane roads, but fails to produce its maximum in smaller roads. They do not provide any flexibility and need to be removed physically when required to do so, causing damage to the surface it was fixed upon. In this project, we aim to make a smarter solution which is economic, reliable, and responsive by using compliant mechanisms.
A compliant mechanism is a flexible mechanism that achieves force and motion transmission through elastic body deformation. It gains some or all of its motion from the relative flexibility of its members rather than from rigid body joints alone. This entirely avoids the need to have multiple different parts for a single purpose, hence reducing weight and cost together. These are usually made out of a single piece of said material and can provide the same if not better output as the traditional hinge and bearing design. So this is a compliant plier mechanism, and some common devices that use compliant mechanisms are backpack latches, paper clips and nail clippers. One of the oldest example of using compliant structures is the bow and arrow.
There are a number of reasons why a complaint mechanism may be considered to use in a particular application. Some of them are right. The first one is part count. One advantage of complaint mechanism is the potential for a dramatic reduction in the total number of parts required to accomplish a specific task. The part count can be reduced by shaping flexible parts instead of springs, pins, and traditional rigid hinges. Production processes. Complaint mechanism can be simple to manufacture because they lend themselves well to various manufacturing processes. Because they get their motion more flexible region, many complaint mechanisms can be fabricated flat from planar sheets of material. The price. Because they have fewer parts and simple manufacturing processes, complaint mechanism can be very inexpensive to manufacture. Performance. Complaint mechanisms have a smaller number of movable joints such as pin and sliding joints. This results in reduced friction and need for lubrication.
Bistable mechanisms are mechanisms that have two stable equilibrium positions within the range of motion. That is, it has the ability to stay in two positions without any power input. Because of this ability, bistable mechanisms have applications in many devices such as switches, valves, closures, and clasps. Compliant bistable mechanisms are a particular class of bistable mechanisms which use deflections of their members to gain motion, rather than relying solely on traditional rigid body joints. Compliant mechanisms represent an elegant way to achieve bistable behavior because the flexible members allow both motion and energy storage to be incorporated into one element. The mechanism that we are using is a modification of the original bistable locking compliant mechanism. The classic BLCM switch requires a force to be applied physically at the switches, whereas a modified BLCM switch will be actuated with the help of servo motors, which would be connected to the compute unit which determines whether the vehicle is within the speed limits or not.
To see if our system could handle the loads in a miniature prototype or in real life-sized models, we went forth and carried out a static stress analysis on a mechanism model at both scales. On a miniature model scale, we assumed a 50 into 50 into 10 mm model made of ABS plastic, which was 3D printed with sufficient support structures, and obtained 5.54 mm of displacement under a load of 10 kilos. On scaling this model to a realistic 14 times the size for real-life applications on a single lane, we obtained an acceptable 77.43 mm of displacement to deploy the speed breaker under a load of 2000 kilos, while having the part still made out of ABS plastic. We further aim to study more about the materials feasible to use for this purpose, which are much stronger and fatigue resistant compared to ABS plastic. A detailed simulation for both studies will be attached along. To give you an idea about the concept of our project, this is an animation made by us on Blender 2.8.
Hello, respected teachers and friends. This is Siddharth here, and I'm here to explain the design and fabrication of an ROV for underwater exploration, which was done under the guidance of Mr. Kirti Kumar N. And these are the contents of our project, and these are what we have gone and done till now. So coming to the abstract, here we choose an ROV for this project because we felt that there has been a lack of underwater surveillance and underwater study of deep water lakes and also deep water oceans, due to which people lack understanding of the various contents and the biology present inside the oceans. So ROVs are one of the best way to study these deep water bodies. So coming to the introduction here, what is an ROV? ROV is an unmanned underwater vehicle, which means that It's just like a drone, but it goes underwater. So it's used for inspecting, survey, and observing underwater objects using camera and sensors. So its current industry applications include military and homeland security, surveying, nuclear nuclear industries, oil and gas, municipalities, and it's used in cinematography for underwater shots, and it's used in science for surveying lakes and other water bodies. So IROV is the only company in India which operates ROV in a commercial scale, and it has tie-ups with various clients, as you can see in the top right. And its applications include maritime applications, ports, bridges, dams, oil and gas. Coming to the design, the first part of this project, which is a design. Under design, we have to follow various steps, and these steps include definition of problem statement, identification of parameters, selection of materials, determination of forces, and design. Going ahead with the first step, which is definition of problem statements, we had to foresee Bangalore lakes so as to make sure that we can do a study of lakes locally in our area itself. So we had gone through various news articles and various studies regarding Bangalore lakes, and we found that Halsuru Lake is the best fitting and is the lake which we can try our experimentation on because it's one of the deepest lake in Bangalore, and due to which if the ROV works in this lake, it'll work anywhere in Bangalore. The temperatures are between 3 to 50 degrees Celsius. Working depth is 0 to 100 meters. 100 meters is just considered here, and its pH must be greater than 6 and less than 8. And any type of lighting would give us better vision. So going ahead, this is a sample study of Alsuru Lake, uh, which has an area of 1.5 kilometers square and is fed by three drains, and as you can see in the slide. So the main problem of Alsuru Lake is the amount of oxygen content, due to which there are very less water organisms, and due to which there are no biological signs as of now, like there are very few. So basically it can be restored, but it needs to be studied before being restored. So that's the intention of a project, to study lakes which are of similar conditions so as to restore them. And coming going ahead with the next step, which is selection of materials. So we had to select something which was cheap and which was actually going to serve the science behind our project. So we chose a PVC pipe, and as you can see the properties here, and also the factor of safety is the best fitting for PVC schedule 40. So we choose PVC schedule 40 pipe. Going ahead with the next step, which is determination of forces, we determine the buoyancy, center of gravity, center of buoyancy, its dynamics, its drag, and according to that we make a model, and we go ahead to make sure that the center of buoyancy and center of gravity are aligned together so as to maintain stability. And you can see, as shown in the figure, that we have got the science behind how to maintain the stability. So we had to just make sure that the center of buoyancy and center of gravity are just very close by, being the center of buoyancy a little higher and the center of gravity a little lower, so as to maintain stability and not produce any torque sideways. So, and determination of force acting on the body. As you can see, there are force acting inside the cylinder and outside the cylinder too. So we had to calculate them. And after calculations of the sample, so we found out the various, we made a model in Fusion 360 software, and we found out the various properties and the various area and values obtained. So here is the area density of each part, mass, volume, and physical materials we used in both the water displaced and solid model. And Here we use Archimedes principle so as to get the center of buoyancy. So in Archimedes principle, the amount of water displaced outside is the amount of buoyant force acting on the body. So that is what is used, and this is the values which we get. And going ahead with the axis. So this is a front view, side view, top view, and isometric view of the axis. So here we make sure that the thrust axes are well set and it's stable enough so that we avoid any spinning or toppling or any other forces which spoil the mobility of our ROV. So these are the final designs after our research and after a lot of calculations. So this here is a rendered model of it under rim lights. And over here we have the stress analysis of the same. And in case we didn't get this stress analysis, it would be for sure that this material would fail underwater. But here in the stress analysis, we considered 100 meters of depth, and it was found that the material can bear 100 meters of depth. So basically, this model is best fitted for lakes in Bangalore and can be used anywhere where the depth is less than 100 meters for surveying. So analysis of water quality parameter. So this includes various values which we need to get through the sensors, and these values are put into quotients and formulas where we get particular answers and where we can actually find out the measure of biological systems in the body like algae and amount of light absorbed and scattering reflection absorption of light as well. Going ahead, we have the cost analysis. In the cost analysis, we considered various electronic parts and of the project, and these are the costs which we get according to what we found online. And the last but not the least is the challenges. So, what if the electronics fail? So, in case the electronics fail, the thrusters are going to stop, but there'll be a positive buoyancy on the body because we are making sure that our body, our ROV is positively buoyant. So due to this nature, it's going to rise up automatically and come up to the surface. So if electronics fail, it's going to come up automatically due to positively buoyant nature. Next, what if the central cylinder cracks and the water enters inside? So water seeps inside, not enters inside. So basically, obviously, the electronics are going to fail, and we are going to make sure that we have a protective plastic casing on the electronics so that it doesn't get damaged. So there'll be a moisture sensor. It's a plan which we are thinking of. It's very highly unlikely that the central cylinder cracks. But yes, if it cracks, we are planning to make a moisture sensor which detects signs of water and it deploys an airbag due to which there is positive buoyancy and the ROV rises up. And then water seeping from the joints. So this is addressed with PVC cement, which is used in our homes, which is used in bent pipes in our homes so as to seal the joints. So that is the best way to seal them, and this is why we use PVC joint. And by this, we address all the challenges, and these are all the results. Thank you so much. This is our project, and have a nice day. Thank you.
Welcome to the project-based learning of the odd semesters. Project work material analysis submitted by Kritik N, T. Devchiran, Mane Paniraj Anvit, K. V. Yatindra and Spurti D.V. This is done with the guidance of Dr. Santosh Kumar, Assistant Professor of Mechanical Department. Material analysis or testing of material is an experimental approach to investigate the mechanical behavior of materials. Herein, we are using aluminium bronze alloy as a material to be analyzed. Aluminium bronze belongs to the family of copper based alloys, offering a varied combination of mechanical and chemical properties. Its typical composition comprises of 80% of copper, 10% of aluminium, 5% of nickel, 5% of iron. It also contains small amount of bronze added to copper. Plasma spray technique. It is basically a spraying of molten or heat softened material onto a surface to provide a coating. Here, the material in form of powder is injected into a very high temperature plasma flame where it is rapidly heated and accelerated to a high velocity. The hot material impacts on the substrate surface and rapidly cools, forming a coating. Using the plasma spray technique, here we carry out our project. A flange and a bush is taken. The bush made of aluminium bronze alloy is then processed for the plasma spray. Here in the spraying technique, the bush is sprayed in the inner and outer diameter and then let for cooling. The cooled bush is then allowed for grinding to get a shiny finish. This shiny finished bush is then processed for the shrink fit method. Here we use liquid nitrogen to fit the bush into the flange and then we obtain with the finished product. These are the pictures related to our project. In the first, it's the old flange. In the second, flange fitted with the bush made of aluminium bronze alloy. In the third, we get to see bush made of aluminium bronze alloy. In the fourth, we get to see the plasma sprayed bush and then a finished coated bush. In the fifth, we get to see the finished product. Using aluminium bronze alloy in plasma spray technique, we get to see various properties of aluminium bronze alloy. Here, it showcased high strength, low fragility, varying degrees of magnetic resistance, low corrosion capacity, non-sparking characteristics, and resistant to erosion, softening, oxidation at any elevated temperatures. Thank you.
Hello, everyone. We are from the fifth semester mechanical batch, and this is the project based review on motor generator unit ventilator by Ibad Kausa, Darshan S, Bivan Kalita, C. Chinmay Prasad, and Charishma Indudara. So basically, our project is about, so first when the wind energy, so when the wind yeah so yeah generally wind energy is a renewable energy, and it it does not cause much pollution, and our project is all about generating electricity with the help of this wind energy. And our project model is a roof ventilator with a small, which is like, it has a small DC generator, and it could apply for general electricity, and it could be used for various domestic purposes as well. um yeah Next, moving to the image. Yeah, so this is the abstract information about how our project is. The hot air that is produced on the roof, it goes to the ventilator, which is our model, and the hot air converts into cold air once it's released outside, and this is got into a form of energy, and this energy is generated and turned into electricity, which is for further use for domestical purposes. Further explaining the construction, and okay, first we have our air ventilation turbines. It can generate electricity even at the temperature, like the temperature of the building, even if the temperature of the building is reduced to a certain degree Celsius, it's still applicable. Going to the construction part of it.
The DC generator is connected to the ventilator. So as the ventilator rotates, the DC generator the shaft of the DC generator rotates and power is generated. And to show that electricity is generated, we are planning to fix an LED bulb which will be glowing. This is the internal circuit of the DC generator. This, as you can see, this is a step-up transformer. Since the power generated is really low, we need to step it up so that it can be used for applications. This is our circuit, and we will be using an inverter after the DC generator to convert from DC to AC. Thank you. This is our project, and we will be developing further on this in the days to come. Thank you.
Thank you.